All right. Left off yesterday getting into Chapter 5 stuff where we learned about polynomials as opposed to, well, everything else that we already knew from Algebra 1. Up until this point, it was all same old, same old. It was a review of Algebra 1, maybe a little extra spice to it, but nothing new. Then we hit polynomials. We had root theorems, or theorems on polynomial zeros, that says, if I'm going to solve one of these things, boy, do I need some help. Because there's an infinite number of things that it could have been. But then I do this theorem, and it turns out there's only this many. Then I do this theorem, and it turns out there's only this many. And maybe instead of having to guess and check a billion things, I only have to guess and check 16. And of those 16, I know that I should start with the negatives first, because of thing. That's what this is. If I got a cubic, how many possible real roots are there? 3. Right? The cubic, it could look like this, or it could look like this, or any combination thereof. If my x-axis is right here, that's got one real zero, that's got one real zero, both have 2 imaginary zeros. But I could have something like this, where we still have 1 real zero, but this one's got 3 real zeros. I could have something like this, where this one still has 3 real zeros. Do you remember why it's still 3? That looks like a parabola. That means it happened twice. It's a repeated zero. This happens twice and then that one. So there could have been up to 3 real zeros. Determine how many positive real roots, negative real roots are possible. List possible rational zeros. So these are 2 different theorems. The possible rational zeros are all the factors of your constant term over all the factors of your leading coefficient, called the rational root theorem. So I list out, there's a plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Because we could have had 1 by 12, 2 by 6, 3 by 4. Either one of them could have been negative over all the factors of 3. Well, plus or minus 1 and plus or minus 3. But I don't leave it like this. I write it out as the actual list. Also, writing all those pluses and minuses was really annoying. So I like to do this, plus or minus the list. So we're going to take all this stuff over 1. 1, 2, 3, 4, 6, 12. Then I'm going to take all that stuff over 3. 1/3, 2/3. I'm not going to write 3/3 because that's 1 and it's already here. 4/3. 6/3 is 2, I already got it. 12/3 is 4, and I already got it. So that's just my list. So that's all my possible rational zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've taken an infinite number of things and said if synthetic division works and I get rational zeros, I've got these 18 numbers to try instead of a billion. 18 is better than a billion when I'm guessing and checking. And then along comes this fellow called Descartes. And he says, if I do the function of a positive x and count my sign changes, If I put a positive x in any of these, they are not going to change. So that's plus, plus, minus, minus. You remember what we did with that? We count. This had exactly one sign change. So there is one possible positive real root, which means when I do my synthetic division guess and check, I'm going to start with the positive numbers because I know there has to be a positive real root. When I plug in a negative x, remember the trick? Because this is going to be a negative times a negative times a negative, 3 of them. So it's going to go negative. This is going to be a negative times a negative, so it's going to stay positive. This is going to be a negative times a negative is a positive. And constants, well, there's no x there, so it's going to stay negative because I can't change it at all. And I count my sign changes. This time there was 2. There's a trick here. They always went down in pairs, 2 or 0. Possible negative real roots. And it's 2 or 0 because, we'll take that cubic again. Let's take a generic, there we go. See, right now, this thing has 2, actually, let's move it over this way. It's got 1 real positive root. It's got 2 negative real roots. Crosses the axis. But if I do this, you see how no matter how far up or down this goes, it's always got at least 1 real 0. Because odd functions start at plus or minus infinity and go to its opposite. As soon as I cross that boundary right here, it still has 3 real zeros. 1's repeated, but as soon as I come up here, 1 real 0, 2 disappeared. That's because imaginary zeros happen in pairs. Imaginary zeros have an I. I is a square root of negative 1. Square roots have plus or minus. So they always go down in pairs. What if I do this of a negative x and I get 5 sign changes? Because they always go down in pairs. It's 5 or 3 or 1. And you do have to write that, 5 or 3 or 1. Now, this is how you narrowed it down. So if I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, plus or minus, 18 things to choose from, I know one of them's got to be positive, if it has any real roots at all. Well, it has to, it's cubic. I've got a positive real root. I have one. I know there is. So I'm going to start with positive numbers. I have 9 things to guess and check instead of a billion. Well, that makes life easier. But there was an easier way. Do we remember it? If I just say, bam, there's a polynomial, solve it, do it. Synthetic division until you get her down to a quadratic, and then deal with the quadratic however you're gonna. So I could take all the factors of 4 over all the factors of 1. I could say there's no positive sign changes in there, so I know that there's no positive real roots. So I'd start with a -1, a -2, and a -4. I'd guess and check with those. Or, y'all remember this business. I shall gaze into my crystal ball. x to the third plus 3x squared plus 6x plus 4. And I will look at said crystal ball. And I'll say, you know what? I feel really good about trying -1 first. I just got a feeling. So, I'll say 1, 3, 6, 4 by synthetic division. And I'll start with a -1. Drop it like it's hot. -1 by 1 is -1. Add them together, get a 2. Multiply them, get a -2. Add them together, get a 4. Multiply those, get a -4. Add them together, 0. Yay! Or longhand division, if that's your jam. Most kids it wasn't. I get here. I just took a linear factor out of a cubic. So what's left? If I take a degree 3, I divide it by degree 1, it's now degree 2. So this now says 1x squared plus 2x plus 4 times x plus 1. So can I factor that? What factors of a positive 4 add up to positive 2? Ruh-roh. That ain't happening, right? So you got to go to complete the square or quadratic formula, whatever your jam is. For benefit of those coming up to the big leagues, x squared plus 2x equals -4. Half of 2 is 1. 1 squared is 1. Write that as x plus 2. X plus 1, the quantity squared, is -3. Solve by square roots. Move it over. For most folks, however, you're going to probably prefer quadratic formula. -b plus minus square root of b squared. Please use parentheses when you do all this. Minus 4ac all over 2a. -2 plus or minus, that's 4 minus 16 is -12. -12 can be written as -1 by 4 by 3. So square root of 4 is 2, square root of -1 is I. And split your real friends from your imaginary friends, and then reduce. I don't care which way you go. If you're cool with complete the square, go for it. In the last couple of years, in Algebra 2 anyway, I think I've had a total of 4 kids who actually preferred complete the square when given the choice. I don't care which you do. I care that you did synthetic division to get the quadratic, then you solved the quadratic. And make sure you write your answer. Find all the zeros. X was -1 and -1 plus minus I squared of 3. Or square root of 3i. Same thing. But y'all, how am I to know on these problems? How do I know that when you did a guess and check, you just got lucky the first time versus you looked at your screen to see what to do the first time? Okay? There's no way for me to know any different, so I'm just going to assume that all of you are incredibly lucky. Okay. Constructing polynomials. Remember that if I say x is 3 and negative 5, I would do this. Right? Same thing works for these. They're just bigger and uglier. You can go completely distribution bonkers on it and say x minus this thing if 4 minus square root of 5 is a 0, what else has to be? Plus x minus 4 plus root of 5. If 3 plus I is a 0, x minus that is a linear factor. If 3 plus I is a 0, 3 minus I is likewise a 0. So I'd turn that into x minus 4 plus square root of 5 times x minus 4 minus square root of 5 times x minus 3 minus I times x minus 3 plus I. This is how it's done in the book. X minus the 0 is the linear factor, no matter how ugly it gets. And then you just got to go distribution bonkers on it. I'll say this part. I'm going to turbo this out. X by the stuff is x squared minus 4x minus square root of 5x. Negative 4 by the stuff is negative 4x plus 16 plus 4 root of 5. Square root of 5 times the stuff is plus square root of 5x minus 4 square root of 5 minus 5. X squared minus 8x. Cancel down, 16 minus 5 is 11. X times x is x squared, x by negative 3, negative 3x. X by I is plus ix. Negative 3 by the stuff is negative 3x plus 9 minus 3i. Negative I by the stuff is negative ix plus 3i minus I squared, which we now know is a negative 1. So minus minus 1 is plus 1. You notice that in both of these, you ended up with whatever this term was, you had 2 of them. And you had it squared. Whatever this term was, you had it squared. Whatever the combinations of them were, they canceled out. Whatever the combinations of them were, they canceled out. This thing, squared. This thing, I had 2 of them and I had it squared. You remember there was a formula that went with this? Instead of having to do it all longhand? I can get rid of all this extra work. Womp, 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 womp. By saying, this is a compound 0 without an I in it. X squared minus 2ax plus a squared minus b squared. This is a complex 0 that has an I. x squared minus 2ax plus a squared plus b squared. I don't have to do all the extra work. I just plug numbers in. X squared minus 2 thing x plus thing squared plus thing squared, shoop. And I say there's an a, there's a b. 4 square root of 5. Getting x squared minus 8x. 16 minus 5 is 11. Look at how much faster that is. Yep.
So, how do you tell if it's a plus b squared or minus b squared?
I, you add them. No I, you subtract them.
It just has an I.
Because if the I gets squared,
Oh, that's always
it's a -1 times thing. So it'll change this difference of squares business. Okay, this one, there's an A, there's, oh, remember that the B is always what's in front of the I, not the I itself. The I is taken care of in the formula. So I'll put a 3 here, a 3 here, a 1 here. Getting x squared minus 6x, 9 plus 1 is 10. Unfortunately, we ain't done. You still have to finish it off. Multiply the 2. X times all the junk. X squared minus, frass a stupid dragon. X to the 4th minus 6x to the 3rd, 10x squared. Negative 8x times the stuff. Negative 8x cubed plus 48x squared minus 80x. 11 times the stuff is 11x squared minus 66x plus 110. And finally, jam it all together. What's that? 58, 69. Yeah, nice. 69 x squared minus 146x plus 110. You're able to cut out half or more of your work if you know those formulas. Like I told you back in chapter 5, those formulas are nowhere to be found in any math textbook I have ever worked with. But every math teacher worth their salt tells kids this in Algebra 2. It's just a time saver. Please slow down when you do these. Watch all of your multiplication. Try to keep it organized. You notice that when I was doing x squared times this stuff, and then I switched to the next one, I still kept them lined up. I shoved everything over, basically a place value. Because it's, boy, is it a lot easier. I don't remember, were there any of you that liked doing these the Punnett square way instead? Like that? I always get that 1 or 2 kids that this is their jam. They just rather do that. I mean, the whole lot of you are either in or have been in biology. You remember doing the little table? You make your little space babies or whatever they are, right? Dominant recessive genes. Like those Punnett squares. I My genetics come from a tall person and a short person. They are literally a foot different in height. My wife's family, on the other hand, they're all a bunch of Oompa Loompas. My kids are not going to be tall. Like the one is built like a little brick. He's solid, but he's short. You ever seen the Croods when Thunk comes running out of the cave and like bowls over his dad? That's my 1-year-old. All right. Modeling data. And it just says an appropriate model. It doesn't even say what to do. We did regression throughout the semester. Multiple times. And this just says, hey, do the thing. And I'm not really sure what to do with the thing. So I better dump it in my calculator and get a look at it first. Just like our one variable stats. Stat. Edit. I'm going to put things in my lists. Before I go doing it, slow your roll. Wasn't there something about years and tables and data? Right? If I put in 1950, that's fine. I can do that. But I am going to get a regression model that goes back to the year 0. And I'm pretty sure that the world production in silver in the year 0 is going to look kind of funky. So what do you want to do? You change this. And when you do these problems, you write it next to it. You tell me what X is. You want to go X is years since what? Go since 1950, because that was a nice starting point. Okay, so I'm going to change this instead to 0, 5, 10, and 15. Zero, 5, 10, 15. Head over. 63, 23, 99, 67, 75, 05. Just to show you what it does. Yeah, I see you looking at me like, what? Hey, finish the sentence. What if I just forgot to put that last one in? When I go to turn my stat plots on, just because it says quit doesn't mean just quit. Read what it says. Dimension mismatch. The size of dimension of lists or matrices. My lists are not the same dimensions. They're not the same size. So I need to go back to my list and see if it's trying to match 15 with nothing. Okay, so just one of those things that you're going to come across if you goof something up. All right. Now I can graph it, and now it's not going to show me anything again. Why not? Oh. Ruining my punchline, man. Okay. I graphed it. I turned my stat plot on. Remember that this is 0 through 15 and like 6 grand through 8 grand. I can manually change the window and say, let's go from 0 to, maybe 30 so we can see even past this. Let's make our y's go from maybe 6,000 up through 10,000 plus. Okay, so I can manually change the window to see things. Did I fat finger a number? Because that looks off. Or is it a cubic? Oh, okay. So how about we zoom stat? We all know that one. Now, if I try to draw a line through this, you are just big old steaming pile of SOL. If I tried to do a parabola through it, it's not going to look so hot. But once you start doing all those kinks in the line, now all of a sudden this might make sense. Because a parabola might try to do this. But a cubic might try to do this. So you have to decide what to roll with. What's the best decision? How do I get a cubic on here? I know that a parabola is probably not going to work. How do I get a cubic in here? Ouch. Start pressing buttons. Figure it out. We did this in like 4 chapters. Hey, stat. Over to calculate. That's why. Because I never actually did it on the assignments. I just wrote down the answer from the solutions to make it look like I did. Cubic regression. Make sure it's the correct list. Y'all have this on your laptop. If you're on the TI-83 emulator on the laptop, this menu doesn't pop up. So to store it, you got to go variables, over to the y's, put it in the function y1. So what it'll look like is it'll say this y1 blinky, 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 blinky. Okay? So it's going to default to list 1, list 2, unless you change them. It's not going to store it unless you change it. Okay. Actually, let's come back here. So now if I graph it, oh wow, that hit perfectly. Random food-related bonus to anyone who can tell me why it hit perfectly. Because it looks like a noodle. That is a cubic is degree 3. There's 4 points. The n plus 1 point principle from back in chapter 5 says, if I got 4 points, there's a cubic that hits it perfectly. If I got 3 points, there is a parabola that hits it perfectly. If I got 2 points, there's a line that hits it perfectly. But you have to make sure that it makes sense in terms of the problem, and that's what we did during this chapter. Because sometimes you'll have the perfect model, but the perfect model says that the average age of a pair of twins in the Ukraine in the year 2030 is -19. And you're like, huh? The average milk production from cows in Wisconsin in the year 2050 will be -5 billion gallons a year. What? Because the model, when you start to extrapolate, does not make sense. So even though the cubic might fit it perfectly, it doesn't make sense in the long run. Now this one, I'm going to see a dip in the silver production and then it starts going up. It makes sense that this will continue to go up. Okay, so you all had the model on there, stat, calculate, cubic regression thing. I get to this. You notice there's something missing off of here? Diagnostics, okay? If I'm on a TI-84, it's just one of my modes. I'm going to turn stat diagnostics on. But if I'm on 83 on the laptops, I have to go all the way to the catalog, all the way to the D's. I have to turn those diagnostics on because now it's going to give me a correlation coefficient. Now it's going to tell me 100%. This is the model because of the n+1 point principle. Okay, so I'd say 12.093x cubed minus x squared plus, I just write her down. I hope that you guys do better with that, especially if you're coming up, because boy, you need to know that. I hate that we have a process in our math curriculum that is completely defined by a specific company's calculator, though. If you're rocking a Casio graphing calculator, which are half the price, but it's menu-based, it's a different type of calculator. So if you're using that, even though it costs half as much, everything I'm doing up here, you're going to have to just figure out on your own because it's a different model. It's a different operating system. It's Mac versus Linus. I always call it Linus because it needs a security blanket with it. But expanding the binomial, I really don't want to multiply out 5 of those. That sheet thing. Or as one kid got in my quote book for, oh, that stupid Pascal triangle. Like, it's not an Easter egg. Pascal. Pascal's triangle. Section 5.7, I think. 5.7? Somewhere in there. Pascal's triangle, you should all have your notes. You should all have holy sheets. You should all have that kind of stuff. Where's Pascal's triangle? Or do you remember how to make it? Could you just make it out to the 5th row real quick? You literally just said 2 numbers, 1 and 5. Should be chapter 5, section towards the end, 7-ish? 7 or 8? I don't know. It was back there. I love that we still have those notes. Y'all, I don't care if you're moving on after this class or not. It is 5.7? Cool. Keep these notes, please. Keep these notes until you are done with your college math. Okay, unless you're going into a STEM field where you know you're going to be doing Calc 2, 3, differential equations, ring theory, non-Euclidean geometry, just nasty stuff. You're going to go to mines and be an engineer. You're going to learn how to blow stuff up. By the way, New Mexico Tech has an amazing demolitions program. They literally do rocket science there. They put rockets on sleds and shoot them at things. Unless you're going that far, your math is probably going to end at college algebra and statistics. College algebra is effectively algebra 2 again, with a tiny bit of pre-calc in it. Tiny bit. So all of these notes, I'm glad that you guys all have the notes. Hold on to them. They're amazing ACT review. They are effectively going to be your notes for college algebra. Okay? Don't just burn them in a celebration of frenzy. Yay, I'm done. Hold on to them. Okay. Pascal's triangle is created by adding diagonal successive numbers. You always stick a 1 on the outside. You say 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 4 is 5. Yes, there's your 1 and 5. 10, 10, 5, 1. Okay? So the expansion of this is going to use 1, butt cheek, 5, butt cheek, 10. Okay, it's going to use this fifth, what the, I caught myself. Plus 10, thing, plus 5, thing, plus 1, thing. And in there goes first term. Remember what I do with my exponents? The first term will start at 5 and work its way down to 0. So x to the 5th, x to the 4th, x to the 3rd, 2nd, 1st, 0. What'll happen in the second part? It'll head up and make sure that you use -3 to the 0. -3 to the 1st, -3 2nd, -3 3rd, -3 to the 4th, -3 to the 5th. And then simplify. Now, if you need to, next to each of these, 1 times thing, plus 5 times thing, plus 10 times thing, plus 10 times thing. You don't have to do this. It helps some people. Writing out what this is. This is x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and 1. Write out that this is 1, this is -3, 9, -27, 81, -243. For some people, it helps to write what each of these things are before jamming it all together as a single term. Then the final answer. X to the 5th minus 15x to the 4th plus 90x to the 3rd minus 270x squared, getting bigger, plus 405x minus 243. Now, as we talk about college and test prep and all that kind of stuff, if you were on an ACT, I would star this and just move past it because it's a time-intensive problem. The number one reason that kids don't get the score they think they're going to get, okay, the number two. The number one is grade inflation, and they think they're awesome, and then they go and take the test, and it turns out, no, you're an average student. But the second thing is they run out of time. They get hung up on problems. This is a time-intensive problem. Same thing goes for when you take these quizzes. I see this problem, I know this is going to take a long time. I'm going to go and take care of my other stuff first and then come back to it. Okay? But if you run across this and you forget what Pascal's triangle is, or I know it's the triangle thing, but I can't remember how to make it and I don't have it in front of me. Okay, then multiply it out longhand. It'd suck, but you can. You just take x minus 3 times x minus 3 times x minus 3 times x minus 3 times x minus 3, and it's just going to take you forever. Unfortunately, our testing system really skews towards who's just a good student. Like, you know, test strategies as opposed to the material. Linear factorization and solve. There's a lot of kids who will say, this. And they'll move on with their life. And they are wrong. That's a cubic. How many zeros am I supposed to have? Okay. I know I have to have at least one real zero because cubics have to cross the x-axis. They have to go from negative infinity to positive infinity. No. There was something called a difference of cubes. Y'all remember there was a big honking chart somewhere in chapter 5, like somewhere between section 5.3 and 5.6? There's a big honking chart that had all the different ways that you can factor. Find it. Had all the different ways you could factor. Somewhere right smack in the middle of chapter 5. There was a big chart and it had GCF, factor by grouping, and then down at the bottom it had this, sum and difference of cubes. I hope you have it. I actually use that chart, that graphic, and I show pre-calc when we review this. Five something. Section 5.3, right behind the first slide. Big honking chart that had all the different ways to factor. Whoo boy, would that be a handy thing to have a little sticky note or something next to that before doing this. That would also be really handy to have if you're heading up to pre-calc, because it is expected that you know how to factor. The difference of cubes says if I have a minus b, stop that. If I have a cubed minus b cubed, it factors into a minus b times a squared plus ab plus b squared. Not to be confused with the sum of cubes, which says a cubed plus b cubed is a plus b, a squared minus ab plus b squared. They change up the signs on us. Okay? Once you have that, you just jam the right things in the right spot. And I say, what cubed makes x cubed? And what cubed makes 125? So I'll jam x and a 5 in everywhere I see a and a b up there. Nope. Because the difference of cubes is taken care of in the formula. So this is going to factor into x minus 5, x squared plus 5x plus 25. So yes, we were right-ish at the beginning of this that x will indeed equal 5. That's the real solution. I got to go find the two imaginary solutions. Do whatever your jam is. Complete the square or quadratic formula, I don't care. Go find the other two. You missed a sign. Not 125, 75.
Peace. Oh, it's this side. Yeah. I had that one. Right.
I know. I was listening to your muttering there. I know. I told you complete the square is easier for me. That's just me because I've been doing them both a long time. Complete the square is broken into steps, and you only ever have two numbers you're dealing with at any step. Whereas quadratic formula, you've got 4 different pieces moving, all doing different operations. In terms of working memory, complete square is actually faster. Now, check me because I am not properly caffeinated at the moment. Yeah? Okay. So whether you do complete the square or quadratic formula, you get the other one. Now it does say to write the linear factorization. So I ain't done. I'm not out in the woods yet. X minus 5 is a linear factor. If these are my two zeros, then x minus those zeros are the linear factors. I don't know why, but I just had the random realization that every one of my friends in real life hates math with a burning passion. My friends, my wife, my family, all of them. Huh. What's up, dude? Oh, cool. You finished? Attaboy. Killing it. Okay. So the difference in sum of cubes, make sure you got them written down or you got it flagged or something. That's one of those new things that we learned in Algebra 2 that I'm probably going to throw at you. In fact, our quizzes are going to focus an awful lot more on the new stuff that we learned, not the stuff we reviewed from Algebra 1. Okay? We got to... I know that you want less problems. You want a smaller final. We're already breaking it up over multiple days, but I also want to make it smaller. Okay. Radicals. If I got a cube root of a thing and a cube root of a thing, cube root of big thing, right? What happens in radical land stays in radical land. You go to Vegas and you see that one person that you know and you're both in Vegas, and you're like, all right, zip codes, right? And then things happen. Okay? Mathematical Vegas, here we come. They're all there now. 9 by 2 by x to the 7th, y to the 7th. If you really wanted, you could make this gigantic. If you get stuck, you have no clue how to do this at all. You can always write it out by prime factors. Say 3 by 3 by 2 by 1, 2, 3, 4, 5, 6, 7 x's, 1, 2, 3, 4, 5, 6, 7 y's. Who gets out of radical jail? Pairs of 3?
Whatever you call a pair of three.
A trio?
Yes.
Pairs of 3. Like, okay, ladies, gentlemen, take note. If you enter in a relationship with Jack, you expect things. 3, 3, 3, 3. So I can take a pair of x's out. I can take a pair of y's out. I don't have enough to take any 3's or 2's out. So I'm going to write that as negative x squared y squared cube root of 18xy. Because I'll jam it all back together. Now, another way to have done this would have been to split this up and say that's 3 squared times 2 to the first, x to the 6th, y to the 6th, x, y. You could have broken it up like that because I want what?
Oh, well, it's Nick's idea, but
The preface. It was his idea.
I'm pretty sure. Even root of an odd.
Okay. Yes, there is that catch. Remember that if I ever take an even root of a number and then something comes out here as x to the odd, that needs absolute value. Yes, that is a thing still. Now in this case, it's an odd root, so it doesn't matter. Because I'm allowed to take the odd root of negative numbers. Furthermore, I have x squared and y squared. No, when I square things, they're going to be positive. So it's going to be positive no matter what. But I could have broken these up looking for exponents that were multiples of 3 to then take them out. This will get you there. This is pushing your vehicle out of the snow. It'll work. This is keeping a bag of kitty litter in the back of your trunk and a tiny little shovel. Shoop, shoop, pour, traction, zoom. Okay? Or are we like, oh, hey, that's actually a decent idea? Yeah. I always used to have a rear-wheel drive truck. Stop it. I will. And I had to throw like 400 pounds on the rear axle. I had to keep sand back there. Yeah. Solve it and check for extraneous solutions.
Well, get the x over square root, maybe square the other side, bang, bang, together.
Do the thing, bang, bang, you got to answer. No, not quite. But isolate the radical. I'm actually going to move this one over just so I have everything positive. Call it x minus 40 is the square root of x plus 2. Just so everything's positive. Okay? I could have subtracted 40 over and added like this. I could have subtracted the x over and then multiplied everything by a -1. I could have squared it like that and worked with negatives. It's all good. This is just my personal preference because, ew. Square both sides. Don't square like a freshman. Because if you say x squared minus 1600 is x plus 2, you done goofed. Remember, it's square this one, multiply and double. If you don't remember that trick, write it out longhand and FOIL it out. It's a quadratic. Get everyone to one side of the bus. Minus 9x minus 1602. I'm betting that's factorable, but I do not know factors of 1602 off the top of my head. What? No? Yes. Man. See, the problem is, okay, in my defense, you're getting a small taste of last year. Baby Bear's 2-year molars are going right now. He had us up twice last night. Chill. Last year, he let us sleep for 3 to 4.5 hours, intermittent every night for 7 months straight. It was bad. I couldn't math at all. Plus 1600. All right, let's try that again. X squared minus 81x plus 1598. It's got to be factorable. I know it's got to be.
Oh, scratch that.
Thankfully, I got a $20 calculator that does something cool the graphers don't. It's got a prime factorization button on it. 1598, math, 4, enter. 2, 17, 30, or 47. So 38, 47. So 80, 94, and 17? No. I don't know if this is. I hope it's not, because that's just gross. A is uno, B is negative 81. Clear, negative 81. Is 1598. 34 and 47, yeah. Oh, 34, not 38. Okay. X minus 34, X minus 47. We'll just assume that we all did quadratic formula and got there, which is probably what you would have done.
So, like, if we had that on the final,
I always put the uglier ones on the review. Always. I would just quadratic formula. Let the calculator do the work for you. I'm not done.
oh yeah, got to check if it works.
If I stick a 47 in the top, 47 plus 2 is 49, squared 49 is 7. 47 minus 7 is indeed 40. But the square root of a number is supposed to come out positive. Am I able to take 34 minus a positive number and get 40? Which is a good time to review back to what are the, what are the commandments of domain? Divide by 0, log a non-positive, even root of negative. I had an even root in my equation. That tells me I have to watch out. The directions don't always tell you to check for extraneous. Fogging off. Remember those, our little Russian nesting dolls? You put this function into that thing. Find f of g. Well, f of a thing is thing minus 7. G is x squared, so put x squared in everywhere I saw an x. So f of g of x is x squared minus 7. Goff, g of f. G is thing squared. That thing is now f of x. F of x is x minus 7. So g of f of x is x squared minus 14x plus 49. Once I square it out. These were new. Expect, guaranteed, you will see this. These are new in Algebra 2. They are needed in multiple math classes afterwards. Expect to see this. Expect to see this, maybe asking for domain and range of them. Maybe asking you to then evaluate and say, find f of g of 4. Then put a 4 in. Inverses. Start with f of x refers to the output, which is y. Then, how do I make an inverse? Swap x and y. Domain and range swap. So this is now x is the square root of y plus 4 plus 5. Subtract. Square both sides. Minus 10x plus 25 is y plus 4. And subtract. When you subtract, make sure that you actually write the correct notation. It's the inverse function of x. Is x squared minus 10x. 25 minus 4 is 21. So that is the inverse. What is its domain? If I was looking at only the inverse function of a parabola, I would say all real numbers. But we have to remember that when I swap x and y, I swap domain and range. So what's the domain of this guy? What's the smallest number I'm allowed to put in there? Thou shalt not take even root of negatives. Can I take even root of 0? Yeah, square root of 0 is 0. So what will make that radical 0? Negative 4. I'm allowed to put a negative 4 in there. Can I put bigger or smaller numbers in? We'll try something. What's a number bigger than 4? That's easy to work with. Okay, I stick 5 in there. 5 plus 4 is 9. Square root of 9. Oh, yep, I'm able to do that. So my domain says x has to be greater than or equal to negative 4. When I put that negative 4 in, negative 4 plus 4 is 0. Square root of 0 is 0. 0 plus 5 is 5. From there, will it go up or down? Right? The bigger the numbers get, the bigger the output gets. So I'd have y is greater than or equal to 5. So when they ask, what is the domain of the new one? It's the range of the original. You take the range and the domain and you swap them. If I swap x and y, I am literally swapping domain and range. What kind of graph is that? No. It looks like a cubic, but it's on its side. Looks like a cubic, but it's on its side. And we just did radical stuff, so maybe this is in the radical chapter. It's a cube root. Remember, a cube root of x says up 1 over 1, up 2 over 8, up 3 over 27, down 1, back 1, down 1, back 8. It's a cubic on its side because it's cube root. And it's still going to follow all that same transformation business that we did all semester long. And I hope now you see why I get so frustrated when my pre-calc kids come in at the beginning of the semester and don't know what a transformation is. What was that? Chapter 1, 2, 3, 4, 5, 6, 7, and 11. 7 out of 8 chapters, we did transformations. Or no, we didn't do it in systems. 6 out of 8, 3/4 of our chapters, we did transformations. So this is the inflection point in the middle. It is currently 1, 2, 3, 4 back, and 1, 2, 3 down. What does that tell me about my equation? H and K. Yep. We've got y is cube root of x plus 4 minus 3. I know that part. Normally, I would go up 1 and over 1, up 2 and over 8. But it looked an awful lot like I went up 2 and over. I went up 4 and over. So my vertical axis was stretched twice as far as it should have been. That's it. Now, again, this is an example. You should be able to work forwards and backwards on these. I should be able to give you a graph and you tell me the equation. I should be able to give you the equation and you give me the graph and the transformations. This is just one example of. Just like our complex numbers, I deal with radicals the same way. What's that word? Conjugates. I'll take the this times a square root of 5 plus a square root of 2. Three by the stuff is a 3 root of 5 plus a 3 root of 2. Negative 10 by the stuff is a negative root of 50. Yes, I'll change it later. Minus a root of 20. Yes, I'll change it later. Downstairs, root of 5 and root of 5 is 5. Root of 5, root of 2 is root of 10. Negative root of 2, root of 5. Negative root of 10. Negative root of 2, negative root of 2 is minus 2. So, we combine like terms. Actually, we've got to simplify first. That goes down. What perfect square goes into 50? You sure? Okay. 20? So when I combine like terms, 3 root of 5s minus 2 root of 5s is 1 root of 5. 3 root of 2s minus 5 root of 2s is negative 2 square root of 2. 5 minus 2 is 3. Now remember before when I said separate your real friends from your imaginary friends? your rational friends from your irrational friends. Well, what happens if all your friends are irrational? You pick the wrong friends. I would just separate the two. Square root of 5 over square root of 3 minus 2 root of 2 over 3. They're different types of radicals, so I would still separate them. You picked the wrong friends. I like it. I may have the wrong friends, but boy, do I have fun. That's a quick way to end up on... Nope. Nope. Caught it. Logarithmic graph. We learned about logarithms. Remember that the calculator doesn't always show the rest of the graph. The vertical asymptote that should have been at 0 moved to the right. Y equals A times log base B of x minus h plus k. Still the same old transformations. New parent graph. So I moved this asymptote right 3. So log base something of x minus 3. The point that is normally here, that is 1 unit away from that asymptote, got moved up 2. So I also have a plus 2. How do I get the base of it, though? You notice it's still 1 unit spaced, 1 unit spaced, 1 unit spaced. So the a value is still 1. That's nice. But how do I know what the base is? Remember, logarithms are about exponents, about powers. Check how far these points are away from the asymptote. 1, 2, 4, 8. Heard it over here. Those are powers of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. This is log base 2. One more down here. The properties of logs. And it does say show some work because otherwise it would have been awful easy to just dump it in the calculator if you had a log base button. Or maybe use the change of base formula. This is asking 4 to what power makes 16? I'm going to take it further and say 4 to the x power is 4 to the second power. Logs were a brand new definition for us. Thank you for hanging on for that. Because the kids who did Algebra 2 second semester last year during shutdown, talking to the other Algebra 2 teachers, kids just quit after Chapter 6. They just stopped doing anything. So a lot of kids come up to pre-calc had no idea how logs even worked. They just decided not to do it. And I hope you would agree that they weren't that bad. Like just a lot of kind of formula property stuff, just move some numbers around. Simplify. What can I do with that 1/4 out front of a log? So it's log base 3 of 162 to the 1/4. Well, this is almost like we're combining radicals with logs. It's almost like it's a review or something. Whenever I have a fourth root of a thing, that's the 1/4 power. Remember, this becomes a numerator, that becomes a denominator. What do I do with a log base 3 of a thing minus log base 3 of a thing? I thought I heard it, but it was quiet. So it's most likely you. Subtract them. Subtract them means, just like with exponents, if I had x to the 4th over x to the 2nd, I do x to the 4 minus 2. Quotients become differences, differences become quotients. Same with logs. That's 162 to the 1/4 and 2 to the 1/4. Since they're both to the 1/4, that's the fourth root of 162 over 2. That can be simplified. That's the fourth root of 81. The fourth root of 81 is 3. The log base 3 of 3, whenever the base and the object match, that big nastiness there equals 1. Tell me, does that make you happy or infuriated when you do all that work and it's just 1? Like, I expect more for my labor. Expansions, if they're multiplied, you add them. If they're divided, you subtract them. I'm not done. What can I do? Exponents are coefficients. 2 ln of x plus 3 Lenny minus 2 ln of z. And if you just drop this ln of 4, you're wrong. This was one of our rut row watch out for this in that chapter. Put a note next to this, remind yourself, if you're expanding things, write its prime factorization before doing anything else. Prime factorization first. I want to get that E by his lonesome. Who's got to go away first? If I got E to a thing, how do I undo it to get X down out of exponent land? What kind of log? Natural log. ln. So I'm going to have, no, natural log is log base E. That's why we're using it. So I'm going to have 3x minus 1 is the ln of 5/4. Just finish it off by adding 1 and dividing by 3. Is ln of 5/4 plus 1 divided by 3. Or you could have written it as 1/3 ln of 5/4 plus 1/3. Either one's cool. Either one is cool, but remember that not if this was a multiple choice test, you would have to know that it's both, because one or the other of these might be written as an answer. Hey now, don't do that. Okay, we're on to the chapter 11 stuff. I know that the bell's about to go ding. What I'm going to be doing here is I'm just going to keep jabbering to myself for the next 5 or 10 minutes. So it'll be on the video. So if you want to go look at the chapter 11 stuff, do it. Do this on your own or watch the video, I don't care, but I'm just going to finish it off so I have it on the site. Okay?
So are we taking part of the final tomorrow?
Yes. And we're going to do it quiz style.
And is it like
Tomorrow, Monday, and tomorrow, Tuesday, and either Wednesday, or no, you guys are third block. Either Thursday or Friday, you can come in and do the last part of it. Okay?
and is it gonna be so tomorrow is it gonna be like the first few sections?
Yeah,
Or,
it's going to go in order.
oh, okay. Like what sections?
It's not gonna be random, it's gonna like kind of.
It'll go in order. Yeah. I don't know. I got to time it out first, and I've procrastinated, so I haven't done it yet. So, for the interweb, hello. These were called combinatorics. When I specifically want this one outcome, I take this combination of things times this combination of things to say how many ways will it happen and how many total ways can I have an outcome of any kind. So we've got 3 boys out of 12. 12 choose 3. We've got 3 girls out of 8 girls. Hi, hold on, I'm talking to the internet. I've got 8 girls, we're choosing 3. Grand total, that means I have 20, choose 6. Then I just jam it in my calculator. That's it. Yeah. There's a formula for this that we had in chapter 11, where it's always going to be the number of things in option A, how many are you choosing? Number of things in option B, how many are you choosing? Number of total things we're talking about, how many are you choosing? That's how we create our combinatoric probability. Or are you just in here to work? Just to finish it? Yeah. Yeah, cool. Are you going to need a pass to Spartan time after this? Okay. All right. Rolling 2 fair number cubes, what's the probability of rolling a prime number on both cubes? A, remember that 1 is not prime, that note is there. Our primes are 2, 3, 5, 7, 11, 13, 17, 19, on and on and on and on, but these are normal D6s, so that's all I got. So the probability I roll a prime on the first one is 3 things out of 6 things, or 1/2. The probability I roll it on the second one is also 3 out of 6, or 1/2. The key is knowing that these are mutually exclusive events. And to find a combined probability of mutually exclusive events, you multiply them. That's it. Now this does say what's the probability of rolling it on both, so it's an and statement. If it said or, you would add the probability here with the probability there. In which case, theoretically, you'd be guaranteed, but you know, that's not actually going to happen. Determine within how many standard deviations the data points of this set lie. State the values at, okay, so they're basically saying make the normal curve for this. So I need my calculatron here. Here, let's move you over. How far can I move you over? Oh, not far enough. I'm gonna second plus 7, enter 2. Second plus 7, enter 2. There we go. I'm gonna reset everything. I'm gonna go back to my stats, edit, and I'm gonna dump all these in. So, 75, 73, see what? 75, 73, 77, 79, 79, 74, 81, 74, 70, 68. So yeah, 70 and 72. Okay, so I got 12 data points. I'm gonna go stat, calculate my one variable stats. So in the middle is gonna go my mean. I'm just gonna shorthand it for now and say 74.3 is X bar, my mean. Then we're gonna go 1, 2, 3 standard deviations out in both directions. And I'm gonna keep adding about 3.9 to it. Again, I'm shorthanding it. So adding 3.9 is 77, 78.2. Adding another 3.9 is 81.82.1. Adding another is 85, 86. Subtract. Hopefully I'm not screwing these up now that no one's watching me. Minus 3.8 is 71, 70.4. Do it again, 67, another thing, 68.5, 65, 64, 6. Okay. Now, this one was labeled this way because it's plus or minus 3 standard deviations. So technically what I wanted was, on a multiple choice, name these two things, and then state within how many standard deviations does my data fall. Well, the lowest that I see is a 68. The highest that I see is an 81. So all of my data falls right there. It went 3 standard deviations out. You always count the biggest in either left or right. If you're going to make the normal curve, you just extend your bars up and actually make the distribution. Sketch a box and whisker plot for this stuff. Again, we said we could do this on our calculator. We don't have to do this the hard way. So I'm going to get rid of him, stat, edit, start throwing numbers in again. 36, 37, 6, 37, 38, 38, 38, 37, 26, 36, 39, 40, 40, 40, 40, 40, 40, 40, 35. 12 numbers again, right? Oh, did I do too many? Is it actually 13 points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So we got all our data points. If I want to sketch my box and whisker plot, we did this back in Algebra 1. We did this back in middle school. Just go to y, second y equals, turn your stat plot on, Do that. And now zoom into my statistics. I missed a number somewhere. That is way off. Stat, edit, right? 36. Is it really that bad? Yeah, it's all a bunch of 30s, 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 and then that 26 was way down there. Wow, this is just a nasty one. Okay, so when you label it, make sure that you actually put these values in. Minimum, quartile, median, quartile, maximum. Also, notice how stretched out this thing is with the whiskers. Boy, if I just put a generic hand like this on my paper, said minimum, quartile 1, median, quartile 2, maximum, and then I just put those numbers on there. 26, what was this, 39.5, 38 and 36. Yeah, I have the right values in the right spots, but it's not proportional. That's important. You have to make sure that you make it proportional. So when you do, please, oh please, even if it is just a sketch, make it kind of proportional. Okay? Extend that out. And that's why we're using the calculator, because you shouldn't have to do this by hand anymore. We're big kids now. And then finally, the last thing, probability trees. There's a 25% chance there's going to be freezing fog instead of snow tonight. If there's snow, 30% chance school will be late. If there's freezing fog, 65% chance, because that is worse. It's going to slick up our roads. So we make a probability tree. And we say 25% chance there's freezing fog. So I'll say freezing fog. F's in the chat, right? Which means snow will be 75%. Says if there's snow, so I'm on this lower branch, 30% chance that we'll be late. This would be on time. And it'll be the corresponding 70%. If there's freezing fog, there's a 65% chance of being late. And that means we'll be on time 35%. What's the probability school will be on time tomorrow? Well, we're going to be on time two different ways. Either freezing fog and on time, or snow and on time. Each of these is a compound probability. So this is 0.25 by 0.35, which is a quarter of 35 is 8.75. So 0.0875. And 3/4 of 70 is going to be 36. 35.5, I think. If I'm wrong, you know what? Here's a calculator right here. Just make sure. Okay. 0.75 by 0.525. Oh, because you added on. See? Good thing I checked. So while I'm at it, I'm going to check the other one because I don't trust myself now. 0.25 by 0.35. Okay. So if these are the two different ways that this can happen, and they are mutually exclusive, they do not overlap. I can't have freezing fog and snow. Well, South Dakota we can, but in this probability tree we can't. I just add those two together. And that's it. So I'll say that answer plus this. So I'll say 61.25%. Okay, it took us an extra 7 minutes, but we did get there. Well, 10 now. Long enough. That is the review. All of it is fair game for the final. Ask if you got questions, remind is a thing.